If you look closely at the surface of our planet, you quickly realize how much every ecosystem depends on the rhythmic movement of the atmosphere. Take the Indian subcontinent, for example. Under neutral climate conditions, predictable seasonal winds deliver regular rainfall. These patterns sustain massive river systems like the Ganges, keeping the surrounding valleys lush and supporting local agriculture. This stability depends on high-altitude reserves, like the deep snowpacks of the Himalayas, acting as a natural water tower that slowly feeds the continent below. Even the traditionally arid zones rely on the predictability of these weather cycles. The sparse vegetation here survives because the dry and wet seasons arrive exactly when they are supposed to. These distinct terrestrial biomes are not independent. They rely entirely on the stability of global atmospheric patterns to function. But that stability is currently fracturing. Thousands of miles away, deep in the Pacific Ocean, a massive shift in water temperature is forming that will break this normal pattern. We know this because the World Meteorological Organization recently issued a global alert. Their latest models detected a rapid rise in sea surface temperatures. Forecasters now have high confidence that an El Niño event will fully emerge between May and July of 2026, intensifying in the months that follow. Because the atmosphere is interconnected, a distant anomaly in the ocean threatens to throw every vulnerable, carefully balanced environment we just saw completely off script. To understand how this works, we have to pull focus away from the land and look out over the central and eastern equatorial Pacific. In neutral conditions, prevailing winds sweep steadily across the ocean, continuously pushing warm surface water west, piling it up near Asia. During an El Niño, those winds weaken. Without that continuous push, the enormous pool of warm water surges back east. This map shows sea surface temperature anomalies. That stark red band across the equatorial Pacific indicates exactly where subsurface heat is accumulating. This concentrated band acts like a giant atmospheric space heater, radiating immense thermal energy straight upward. Because the ocean and atmosphere are physically coupled, injecting this much heat into the sky alters jet streams and redraws global weather routes. The immediate consequence is heat, projecting global dominance of above normal land temperatures. Shifted jet streams scramble precipitation, delivering heavy rainfall over the southern U.S. and Horn of Africa. Conversely, rain over Australia, Indonesia, and southern Asia vanishes, plunging them into drought. What begins as a localized warming of the ocean effectively reconfigures how water and heat are distributed across the continents. Climate change does not cause El Niño, but human-induced greenhouse gases act as fuel. A warmer ocean and atmosphere amplify the heat to extreme levels, like 131 degrees. When global patterns shift, the human cost is immediate. A severe El Niño drought leads to a devastating localized impact on vulnerable agricultural sectors, particularly in South Asia. Simultaneously, the redistribution of moisture causes catastrophic flooding and infrastructure failure in other regions, overwhelmed by the volume of displaced rainfall. Earth's geography determines exactly where a region's vulnerabilities lie. A warmer atmosphere guarantees that when those vulnerabilities are tested, the extremes will be severe. Surviving these extreme events requires early action. Governments and humanitarian groups must use seasonal forecasts to adapt before the rain stops or the floods begin. Tools like the WMO coordination mechanism provide the crucial data needed. By tracking these ocean shifts, water managers can protect resources and prepare communities for the incoming extremes. Our climate is a massive interconnected engine. By tracking subtle shifts in the Pacific, humanity can prepare for the rippling effects across the globe. Analyzing these planetary patterns proves that geography helps us understand our Earth.